I'm going to show you now how we can implement simple logical functions such as AND and OR gate type functions using contact and coil ladder logic programming in a small PLC. I have, in this example, a Micrologix 1000 Allen Bradley PLC with input switches connected so I can simulate different input conditions and I can watch the output statuses with the LEDs over here. Connected to this, I have my laptop computer running Micrologix RS Logix Micro Starter Lite software. So looking at this, I'm going to enter a rung, insert a rung. I'll pull down a contact, and this contact is going to be input 0, 0, element 0, bit 0. I'm going to call this input A. I'm going to draw down another contact here in series, and this is going to be the next bit on my input, so element 0, bit 1. I'm going to call this one input B. So I have two inputs now defined in my PLC, and I've got two contacts, for one for each one of the inputs. I've wired those imaginary contacts in series on the program. So they'll be able to pass imaginary power over to a coil over here if and only if both of these imaginary contacts are closed. I drag my output coil over here. It's going to be output 0, element 0, bit 0. And I'm going to call this output AND. Using the word AND because this will effectively be the AND function. This will receive imaginary power if and only if this contact and this contact are both conductive and passing imaginary power to it. So what I'm going to do now is save this or download to the PLC. Yes, I want to send the file. It's going to ask me now if I want to go back into run mode, and do I want to go online? Yes. So what I have right now is a simple AND function program. If I turn my first input on, input A, that sets the bit for that input channel. The contact reads that bit in the memory of the PLC, and this normally open drawn contact is essentially going to close in an imaginary sense or virtual sense if it sees a 1 status in that bit. This next contact right here, likewise being drawn as a normally open contact, is going to close and pass an imaginary power through if its bit is also in a set or 1 condition. So when I turn both of my switches on, as you see here, I'm sending imaginary power over to my output coil, which is activating the real output. So over to the PLC, if we pan over to that, I see these two switches right here, both in the on position, energizing these two inputs, and I see the single output energize as well. If either one of the input switches goes to the off condition, the output turns off. If both go to the off position, the output turns off. I only get an output on that channel if both A and B are on. So I've implemented an AND function using contact and coil programming in the PLC. Bear in mind the meanings, I should say, of the contacts and the coils. In ladder logic programming, a contact is a read instruction. We are instructing the PLC to read the status of a bit and to take action based on that bit's status. The coil, on the other hand, is a write instruction. When it receives imaginary power, it's going to write, in this case OTE coil, it's going to write a value of 1 to that bit when it receives power, and it's going to write a value of 0 when it stops receiving power. So this is always actively writing a bit value to that place in memory. If it's energized with imaginary power, it writes a 1. If it's de-energized, no imaginary power, it writes a 0. And these contacts over here are read instructions. What I'm going to do now is expand upon my program and add one more function. We've seen an AND function, now we're going to see an OR. So I'm going to insert a new rung here. To do an OR function in ladder logic programming, I need to have parallel contacts, not series contacts. So to do this, I'm going to bring down a rung branch instruction. So not really an instruction, just a construct here. I'm going to bring down two contacts, one right there, and one right there. And this is going to go to a coil. I'm going to identify my contacts. This I'm going to call input A. Now I can simply call it by its symbol because that symbol has already been associated with that bit. And down here, input B. Another powerful meaning of symbols or usage of symbols here. Once I have my symbols established and associated with the addressed bits, this means I can simply type in or reference those symbols and immediately link them to my contact or read instructions or coil or write instructions. So if I have some intelligently laid out or thought out symbols here, it makes it much easier for me to reference them in the program just by typing in that instead of remembering, oh, it's I:0/1. Over here, I'm going to have this go to an output. This is going to be a new output. This is going to be O:0/1, bit number 1 of my output. And I want to call this one output OR. So this output is going to represent the OR function with regard to the two inputs. I'm now going to download this to my PLC. I'm skipping the verify step here. I could normally click the verify button up here and verify the operation of my program, but I'm skipping that right now because I know this program is going to work. So here we have a program running, and we're in the online mode so we can watch what's happening. I'm going to turn my input A switch on right here. You see that passes imaginary power onto my imaginary coil over here and energizes it. I can now turn it off, turn input B switch on. It now passes imaginary power to my coil. So we see this coil powers up if input A or input B is set. So input A set, I get power. Input B set, I get power. Input A and B together, I get power. And that is the only condition up here that works to activate the AND coil. But the OR coil is activated if either one of these inputs A or B is activated. So going over to my real PLC and watching the status of the lights, here are my two input switches, A and B. Here's switch A, I immediately get the OR light, bit 1. Here's switch B, I now get the AND light and the OR light. Here's switch B by itself, I only get the OR light, and nothing. So watching output bit 0, that's the AND instruction, output bit 0 right there. And watching output bit 1, that's the OR instruction, A or B turns it on, or both. So simple illustration, simple example of how we can do AND and OR functionality using ladder logic programming.